Solve. Story problem. A boat moves 28 kilometers an hour in still water. It travels 80 kilometers upstream and 80 kilometers downstream in a total time of 7 hours. What is the speed of the current? Now, unlike work problems that only give you values of time, this one gives us a rate here, a distance here, and a time. It gives us both distance, rate, and time. So the basic equation, distance equals rate times time, is our basic formula to work with. I'm going to create this into a table. We have two situations, upstream and downstream. So I have two columns and two rows. So upstream and downstream. Now when you set up this table, and I do this for all distance, rate, time problems because it works on all of them, I see that I have some simple information like that travels 80 kilometers. That's distance. So both upstream and downstream is 80. Now the rate is the next easiest thing to fill out. The total time of 7 hours, they didn't do 7 hours in one or the other. So I can't just put a 7 in one or the other here. So that makes it a little harder to fill out the time column. But I'll show you how to do that. The rate. Going upstream, you go slower going upstream because you're fighting the current. What is the speed of the current? I'm going to call that R. So going upstream, we're going 28 miles an hour, kilometers an hour. That's how fast our boat goes, but the river slows us down by a rate of R. Going downstream, we could push our boat 28 kilometers an hour, but we're sped up plus the current plus R. So this upstream downstream is when you have like 28 minus R, 28 plus R. Some problems, the R is actually first. But in all cases, your vehicle speed is first, and the river or wind speed is second, because the vehicle will always be faster than the river or the wind, or else you're not going upstream ever. So make sure that you have the boat or the plane or the canoe speed first, whether you know it or it's the unknown you're after. Okay, now, since distance equals rate times time, and we need to fill out the time column, if I were to solve for t, I get time is distance divided by rate. Now I've already filled out the distance in the rate column, so I can fill out the time column by taking the up distance divided by the up rate. And the time for down is the down distance divided by the down rate. So that's how we can fill out the time column. So anytime I do this box, this table, there's always something that just fills out directly. The rate I always fill out as well. And the time is almost always the thing that I fill out with the formula. Sometimes it's the distance that I fill out with the formula, but most of these in this area of mathematics is solving for the time to fill that column out. Okay, now a lot of these problems say in the same time. That means the time up and time down would be equal, and you just set them equal and solve. In this case, it says the total time. So although I don't know what this up time is or the down time is, I do know they add together to be 7. So that is 80 over 28 minus R plus 80 over 28 plus R equals 7. This is the equation that we now get to solve. This is typically the hard part of the story problems, is coming up with an actual math equation to solve. If I just give you an equation and say solve for R, I would probably get a lot better results on an average on a test from this problem. But once you get to this, you do want to have this be the easier part of the problem. So we have a rational equation dividing by variables. So we want to clear fractions. So I'm going to multiply by 28 minus R and also 28 plus R on all three terms. Might take a bit to write it, but it's worth it to have it all consistent. Okay. Now in each term, something different will happen. So we can go through and reduce. Okay, so we're left with 80 times the 28 plus r, and plus the 80 times the 28 minus r, and the 7. Now I'm going to multiply these together. And 28 times 28, 784. 784. Now these are conjugates. The inner and outer products will cancel, and minus r squared. That's not squared. Let's try that again. There we go. So let's distribute now. 80 times 28 is 2240. So we have 2240 plus 80r plus 2240 minus 80r equals, 7 times 784 is 5488 minus 7r squared. Now the r's terms reduce. If we combine like terms on the left, we get 4480 equals 5488 minus 7r squared. Okay, if we move the 5488 to the other side, we have negative 1008 equals negative 7r squared. Now if I divide by negative 7, I get 144 equals r squared. Now that'll actually, if I square root, give me two answers, 12 and negative 12. However, the rate of the current is not negative, so we have 12. What is the speed of the current? 12. The appropriate answer then would be 12 kilometers per hour. Okay, I hope this helps you solve this type of total time, distance, rate, time problem.